I see everyone's logged in. So good morning, everyone. Thank you for joining me for this webinar. The topic for today is creating custom parametric components for infrastructure using Inventor Professional. Yeah, that is a big mouthful, but in simple terms, all it is creating stuff that you can use in Inventor as well as you can import it into Infraworks. So today I'm going to be presenting this, and it's presented by myself, Shuaib Yunus. I am the BIM Technical Specialist, Mining and Civil Infrastructure here at Baker Bains. So yeah, let's just jump in. Okay, so today's session, as always, we always have a quick intro about who we are, who Baker Bains, who we are, because there's always new people attending. So it's just a quick 5-minute intro. And then after that, we jump straight into the thick of things. So we're going to look at exactly what is a parametric component and why use Inventor. You can actually see why. And then, of course, we're going to go into the actual demonstration where I'm going to be using a curb as an example. And then, of course, we are going to conclude. So a quick blitz, quick learning, easy, chilled out session. Okay, so let's look at Baker Bains. Who are we exactly? Right. So as you might know, our mission statement is helping you design and make a better world, and that's exactly what we all thrive on here at Baker Bains. So if you're looking at this slide now, at the moment we got 4 main segments. So it's survey and design. So all of your scanning, scan to BIM solutions. Design software, of course, Autodesk, IDIS, and Adobe. I'm going to touch on that later quickly. We also believe in a blended learning approach where you use online as well as classroom training to get the best at what you want to be. And then, of course, in terms of projects and stuff, we are a BE level 2. And the great thing now is we're an Autodesk Service Provider Select, which is a very niche market to be in. So it's a really cool thing for us to have and to boast about. So that's in a nutshell who we are, and then we help you to design and make a better world. Okay, in terms of the actual industries that we do specialize in, it's of course the build industry, so all of your vertical construction spaces, civil engineering or civil infrastructure, and mining is very closely related. But it's, if you use a generic term, it's more or less horizontal construction. So your roads, your railway lines, your pipe networks, all of those type of things. And then of course you got plant, energy, and mining. Again, energy more on the electrical, heavy current, those type of things. And then of course the manufacturing segment. So as you can see, we have a good spread, in fact, of all of the main design industries, and we've got the right people in the right spaces to actually help you in the specific field that you are at. All right, in terms of the brands that we represent, of course, you all know Autodesk, so we do all of the Autodesk software. We are an Autodesk reseller, but we are primarily a consulting company. It's just one of the byproducts of what we do. And then, of course, it's Leica. So if you're not familiar with the scan to BIM solutions, Leica is used predominantly by interior space or building scanning professionals. Really, really cool. That machine that you're seeing on there is the BLK360, really small, compact, and a really cool machine. If you want to do as-built capture and scanning, you scan the building, you bring in the point cloud, you either extract it using intelligent tools or manually, which is by tracing the point cloud to get a model, and then you have an as-built versus scan. Then of course you've got Topcon. Topcon is more heavy, rugged construction equipment. The one you're seeing there is the Allen 100, is predominantly used by surveyors, but it also has a 3D scanner called the GLS 2000. It's predominantly used on sites, construction, mining sites, and so on. And it does basically what the Leica does, but it's much more catered and purpose-built for construction. And then, of course, the tool that I really love is the CAD Learning. It's our online platform that we are exclusively partnered with, and it has basically majority of all the Autodesk software on there. So if you want to learn Civil 3D, AutoCAD, Revit, Advanced Steel, all of those type of software, whichever you're into, Inventor. There are online videos that you could go through, as well as exercise files that are attached to it. So it's really cool that when you are in a project, in the heat of a project, and you need to learn something, or you've probably forgotten something from training, whether it be on site or here at our classrooms or wherever, you can actually go back, log in, have a look at it, and get up and running. So it's a really, really, really good tool, and I strongly recommend it as a designer, for every designer to have as their tool and backup. So yeah, that's a quick snapshot. Again, we base it on an IDOP methodology that's customly for Baker Bains. It's our secret recipe that we use to help you get up and running. So if I had to summarize it, is we don't just sell you the software, or we don't just pitch you a product, we actually show you how to apply it, how to use the methodology to get what you want, so that you could fish for yourself, if I could call it that way. And that's also the purpose of our webinars. We actually show you how to do things much more easier, quicker, faster, and much more of a sequential, logical way. Okay, so now that you know a little bit about us, let's jump into the heat of the topic, which is parametric components. What are they exactly? If we look at the parametric components, they basically dynamically changed instant-based objects. That's just a mouthful of saying that there's parameters or dimensions attached to it that if you import it into another software, it can be editable. It's not fixed, and it represents a relationship. So all of these parametric components or dimensions or parameters, whatever you want to call them, that you input into a design or into an object, it's all linked, and it can be dynamically changed and affected. So it's a really, really plus thing to have. So you can actually cater or edit an object depending on the size. So you have one object, for example, maybe an I section or maybe a concrete beam or something like that. But depending on your application on your site, maybe the depth will change, the width will change, that type of thing. You could just type in the parameters and it will update rather than drawing it from scratch. So it's a very, very powerful thing to have, and it is basically where you want to be in terms of the modeling and design space. So parametric components are versatile, and they can be used across the AEC and PDM BIM workflows. So AEC standing for architecture, engineering, and construction, and of course PDM, product design and manufacturing. And examples in AEC, which is a space I'm specializing in: bridge components, tunnels, drainage structures, retaining walls, barriers, curbs. I actually did a retaining wall on it yesterday and imported it into Infraworks, and it looked brilliantly. But I've chosen a curb, and I'm going to explain why. So if you did not know what a parametric component was, now you do. Okay, so again, I like to give a good proper introduction and understanding of what the tools are we using, why we're using it, and how does it affect our design, because understanding is much more better than just click, click, click. Okay, so if you don't know what Autodesk Inventor is, it's predominantly used in the mechanical space. It's used as a 3D grade software for product design, engineering, simulation, and visualization, parametric modeling, mechanical, stress analysis, automated frame design. It has a full load of really great tools that you can use. Frame generator, it's dynamic, it's powerful, and it's, like I said, used by the industry professionals in product design and manufacturing spaces. Very, very powerful tool. It is also part of the actual Autodesk product design and manufacturing collection. These are the tools put together or bundled together to help the professionals in this space. You can see CAM is there, computer aided manufacturing, or right? So you could use that. Getting a bit tongue twisted today. It is Friday, but yeah, this is where it's included, and as you can see, it falls part of that collection. So if you do have this collection, you do have Autodesk Inventor already, so go have a look on your computer. And then, of course, Infraworks is in the Autodesk Architecture, Engineering, and Construction collection. So these are the tools that are normally put together to help the guys in mining and civil infrastructure space, the professionals in that space, and Infraworks, as you can see, is in there. So the reason why I always show this is a lot of people have access to these tools, but they only have maybe Civil 3D installed on their PC or Advanced Steel or Recap. You actually have access to this. All you've got to do is log into your Autodesk account or contact your um, administrator of your software in your company. It probably is the IT professional or someone head of the department. Log in and then just download onto your PC and you can use it. So use what you have, don't let it go because it's very, very powerful. So today we're going to bring it into Infraworks. If you don't know what Infraworks is, it's a conceptual design tool, and the way it has been applied in industry today is damn amazing. It's really good. You got industry professionals from architecture, from structures, from civils, from mechanical, all linking into this model, and you're creating one really, really awesome model. Really good visualization tool. If you want to present something that's very technical, but you just want to give a conceptual overview of your design, this is the way to go. If you want to go one step higher, it's 3ds Max. But if you want to just get into it, Infraworks is really, really good. It's really, really good. So yeah, and it also falls in the first and the last part of a workflow if you apply it correctly, and you can link your detailed design to it with just a few steps. Okay, so Inventor, the reason why we're using Inventor for this, you might be thinking that I could probably use Revit, I could use some other software to create a BIM tool or BIM object or parametric object, whatever term you want to use. But if you look at the way industry is going, we have a plug and play mentality now. And what I mean by that is we are doing modular construction where everything's created on site and created in a factory or manufactured, and then it's just brought into site and connected. I call it Lego construction. A good example of this was, I don't know if you guys see it on LinkedIn, that hospital that came up in just a few days. Or if you want to check a really cool one also, I think it was the Broad Group in China that created a 30-story or constructed a 30-story building or hotel in 15 days. It's really, really amazing. And this is happening because of the convergence between construction and manufacturing. So if you have a spec that's manufactured or designed by someone in the product design and manufacturing sector, you could actually bring it into your civil infrastructure design to make things much more easier, so that when you're going to site, it could actually be prefabricated, pre-manufactured, and just brought into site and shipped in and placed in the correct position. So that's why we're using Inventor. And this is not to complicate things or not to make you intimidated, but once you get used to the software and civil infrastructure, the application is very diverse, very, very diverse. Like if you look at the products on there, you can actually end up into augmented and virtual reality, which is really, really fun, really, really fun. But we're not looking at that today. We're actually going to be looking at that part where we're going to do a parametric model in Inventor and then bring it into the Infraworks platform. Okay, so I've given my introduction, I've given you a brief understanding. Sorry for being a bit of a lecturer, but I just like people to have a good background before we jump into things. Okay, so now for the fun part. So normally what I've seen online, I'm sure you've also seen this if you wanted or Googled how to create a bridge component or how to create a parametric component. The most common videos that pop up are the ones about bridge decks or bridge foundations. And at first I wanted to do that, but I said there's so much content on that. Let's just maybe model something different. And I looked at a curb, because a curb for a quick webinar, it's quick. It displays the methodology quite the same, whether you're creating a retaining wall, whether you're creating a safety barrier, crash barrier, drainage inlet, the creation process is exactly the same. So I have taken a curb, and bonus thing is I've actually taken a real world example. So here in South Africa, we have a lot of standard details that we use by different departments. This is one I've found online or got from JRA, Joburg Road Agency. I'm not just pulling anything out of my hat here. We are going to use an exact spec. So I found a mountable curve, and this is what we are going to model, right? it's a small object. Again, the methodology is the same, but you're going to pick it up quite easy. So we're going to model that sans mountable curb for industrial use. We're going to put in the dimensions, and then we're going to import it into our Infraworks model. So let's get into it. Alrighty, so we're going to open Inventor, and we're going to go to a new model, and I'm going to use a millimeter, so metric. Okay, now very important, on the left hand side, you see Y and X, and it's showing over there that it's actually the front view. That is incorrect. The reason why I say that is if you're looking from the top, that's what you would see. You would see a YX from the top. You wouldn't really see a front, if I could put it that way, a front view. So this is actually a top view. And as you can see, we have actually created this in the wrong way. So what we're going to do is we're going to switch to front, and now you see it's actually correct, where the Z elevation is up and Y is there. The next thing you're going to do is we're going to select the correct reference plane, so XZ, and I'm just going to toggle to the front view here, and you can see it is correct orientated because Z axis should always be upwards. And let's start drawing. So in Inventor, you could either enter the dimension directly. However, the correct way or the easy way to do it is to give it a definition. So I'm going to use right of curb, right? Even though this is actually left, but you're going to see why I did that, right? And then we're going to do the bottom of the curve. So BOK equals, and I'm going to enter the measurement, which is 300 millimeters. Then we're going to go up, and then we're going to say, okay, let's see, what would we call this? This is actually not the left curb. It should be the right of curb, but you're going to see why I'm doing this later on, right? So I'm just going to put ROC instead of ROK because it will be the same dimension. And then this one will be the top of curb. Okay, but I'm not going to put in a definition. I just put in a measurement, and I'm just going to join it. Now, the reason why I do this is you're going to see when we're going to extract the parameters that you can go and edit it, because sometimes what happens is when you're drawing, you actually just enter the dimensions very quickly, but you don't put a description. So as you can see, this is what we're left with, right? That's the front. And now we're going to use a simple command called extrude. So the extrude will extrude it along the plane that it is currently. And you can enter a distance. It can be whatever width you like. So maybe a half 500 millimeters is fine. And that's what we have. So you can see the curve was done really, really quickly. Very simple, very easy. You just got to change the view to make it look correct, that the axis is correct. And as you can see, front view, Z is pointing to the top and X is on the correct plane. All right, so we have managed to model this. The next thing from here is now to go and assign parameters to the components. So as you saw in the video that I've done, is some of the dimensions I've entered in incorrectly or I made a typo. That's a common word we use. Alternatively, I've just entered, like for the top of curve, I just put in 25. I did not put TOC or TOK equals, right? You can always go back and revisit it. The only reason why it's better to put it in while you're doing the design is if you have a lot of dimensions or a lot of parameters like you've seen. For example, if you look at a retaining wall, it has a lot of kinks and a lot of angles and a lot of depths. You might actually get confused which dimension equals what. So it's much more easier to do your design in the correct manner, sorry, than being in a corrective mindset, if I could call it. Okay, so let's get in here. So this is where we stopped. We're going to go to the Manage tab in Inventor, and you can see all the parameters that we've entered are on here. The ones that we have not given anything are D3, D4, D5 by default. So you can see I'm changing the ones that I made a mistake. So the left of the curve was 100, back of curve is okay. This was the top of curve, right? So TOK, right? It's not TikTok, but it is TOK. And then right of curve there. And then the 500, it was the actual length. So I'm going to type in length. And then, of course, the ones that you don't really want, I don't know what to call this. So maybe hypotenuse or HYP, I don't know, but you guys will be much more better at labeling stuff than I am. And then we're gonna tick the key option in Inventor. So what this does is it creates the key parameters that we can now export. And if we go to the environments tab, we're gonna use the infrastructure part shape utilities. Damn, that's a long title, but we're gonna use that. And we are gonna export it to the way that we want it. So you can see there's our export here. When you click that, this wizard pops up. I'm happy with the way it looks. You can go browse as to where you want to save it. You can give it a name. If you have an asymmetrical road or with different curbing, you can say right curbing, left curbing. Alternatively, you could have just called it mounted curb, sands, whatever. Give it a good name, because you'll see now when we get into Infraworks, you could actually invert it or use it on both sides. But just for this example, I've said right curbing. Okay, so now that we've exported the parameters, the last step will be is to import it into Infraworks for use in civil infrastructure design and modeling. Again, Inventor is compatible with a lot of different software. You can import it into different catalogs, different specs. I've just used Infraworks because it is like the main software that's being done or used in industry at the moment. It's a really hot topic. Okay, so what we're going to do here, this is my Infraworks model, and I am going to go to the content catalog style. I'm going to go to parametric models, and the common thing that people do normally is they go here to import stuff. All it does is it creates a new folder, so don't do that. Okay, or otherwise you'll have a lot of empty folders. If you want to import something, you go to the one at the bottom. So once we've imported this, I'm just going to navigate to the one I created, right, curbing.ipt, and this is where you can specify the domain. So I'm going to put it, for example, under city furniture, or you can put it under generic. You can see the preview at the bottom looks pretty good, exactly like what we modeled. And then there's all the dimensions that came through, all the parameters rather. This is what's so good about parametric modeling. I can go still edit these labels in Infraworks if I'm not happy with it. I can also make it visible so other people, or if you have it in the library, it can be editable or not. So I can toggle the dimensions that I want to be fixed. It's really, really good. So parametric modeling is the way to go. So once I'm happy with that, you see it's appearing now in my Infraworks style palette. And I'm going to go to this road here. Okay, if I select the road, center line, you can see it's Witcher Avenue for my first webinar. We are going to go and place a decoration. So that's the option you're going to be using. All right. So let's clear this and let's type in right. Here we go. So decoration, and I'm going to assign it on the right hand side of the road. So let's click there quickly. Yeah, so here we go. As you can see, it comes in first like this. So if you do see this, don't get alarmed or think it's wrong. All it needs is a little bit of orientation. So I'm going to delete that curb that I had because I'm not going to be using that anymore on my road. Okay. And what we're going to do now is we are going to sort out the orientation of the curve that we brought in. Okay. So here it is. Let's just get a good view here. I think that should be fine. You can see all my parameters came through. These are all fully editable now. So you can see the impact of parametric modeling. It's amazing. Okay, so the spacing, I'm going to just adjust this. No, let's just delete this a little bit. Let's make it 0.1. That's fine. So we enter that. All right, you're going to get something weird like this. Now, I want to show you that it's really nice that while you're editing stuff, you can actually see how it looks in your model rather than hitting and hoping. So as you can see, I'm playing around with the orientation. That looks perfect for me, but however, it's orientated wrong. It should be in the inverted direction. So if I type in 180, all right, let's see if this is correct. Nope, that is still wrong. So the correct direction actually will be 270. So you would, of course, you would know this much better than I am, but I'm just showing this to you that you can actually play around and see if it's looking correctly or not. And that's quite fine. I don't want the sidewalk, so I'm going to delete the sidewalk. Here we are. And here you go. Look at that. It fits in perfectly. Here's a good cross-section view. It ties in at the correct space. And yeah, that is it. So you can see it's quite a good workflow. The Inventor part will take a little bit of practice if you haven't used Inventor. I'm not an Inventor specialist, but I just know the little bit parts about the parametric modeling. So yeah, let's wrap things up for Friday, right? So this is what we did. We took the Sans Figure 8C curve. So I took a real spec. I created it in Inventor by using an IPT millimeter or metric. If you're in the US or Europe and you're tuning in, of course, you'll be using imperial. Once you do that, you will assign the parameters depending on what you want. So top of curve, bottom of curve, left of curve, whatever convention that works for you. You'll put in those parameters and you will be good to go. And then of course you're going to export it using the infrastructure parts shape utilities function. That is the damn mouthful, but and then from there you're going to import it into your Infraworks under the style palette, drop it in, and then of course use your orientations, whether you want to tilt it, whether you want to rotate it, whether you want whatever you need to do, you can do it in Infraworks. Look at it visually to see if it's correct and you're good to go. So this is really nice, and this is the power of parametric modeling. Again, if you are in the civil infrastructure space like I am, or you're a civil engineer, road designer, structural engineer, or whatever, Inventor will take a little bit of getting used to. But if you're going to use it just for modeling parametrics like what I've done now, it's pretty simple. If you can use AutoCAD, you'll find your way around for Inventor much more quicker. So yeah, that's just my wrapping up, and that's my webinar for today. Thank you very much for joining me. I'm gonna just, if you want to get into contact with us, Baker Bates Online, we're on LinkedIn, Facebook, Twitter, Instagram, and YouTube. So if you had a friend or tag a mate that you haven't been able to actually attend this webinar today, we will post them on our YouTube channel. And then, of course, I always use this designers assemble, right? If you want to connect and chat about design or anything cool in industry, please reach out to me. I'm very open to interacting with people in the same industries. Even if you're not, if you want to say hi, grab a coffee, chat about design, I'm fairly open to it. You can reach me on LinkedIn. I'm very active on this, so if you just Google my name, Shoaib Yunus. Or alternatively, if you'd like to reach out on email, the reason why I put this is if there's something that's bothering you in infrastructure space that you're struggling to model or design and you don't know what the hell's going on, send me a request. So like drop me an email, drop me a LinkedIn to say, hey, I'm struggling with this type of aspect. And who knows, maybe in a month or two, we could actually cover it in our webinar. So we try and help you guys in terms of design. Again, my core product that I specialize in, that I'm a bit, I would say, decent in, is Civil 3D, Infraworks, Recap, Vehicle Tracking, AutoCAD, and BIM 360. And then, of course, I've got the secondary products, which are in the structural game, which is Advanced Steel, Rivet Structures, Robot Structures, and Navisworks. And then, of course, the webinar recordings. You can catch all my civil infrastructure webinars on Baker Baines, my YouTube channel. We put it on a civil infrastructure playlist. So if you want to go directly to that, you can always contact me. I can send you the link. Alternatively, just jump onto YouTube and type in Baker Baines. That's as easy as it is. All right, peeps. So thank you very much for joining us for this webinar. If you have any questions, if you have any suggestions, if you have any comments, any recommendations, please reach out. Please send me an email, drop me a LinkedIn. Follow me on LinkedIn because a lot of this content is posted on there. And yeah, I hope you have a really, really awesome Friday, a great weekend ahead, and catch you for the next webinar soon. So have a good day and goodbye.